So now let's go together and answer this question. It's very similar to the previous one, but the difference is that instead of 3 genes, we have 4. Okay, so let's read it together. What is the genetic map given the following recombination frequencies? So again, they gave us a table with the genes, and here we have the between gene A and B, the recombination frequency is 15, between B and C is 40, and between the other genes they also did the same thing. So remember, the order of this gene is not going to be A, B, C, and D, yeah, or it could be, but it's not for sure, yeah. So we need to test that, and here are the potential answers. Now you can stop the video and try to solve the question. And in the following slides, I can show you how I would answer the question. Okay, so let's start. So the first thing that I would do is try to go for the longest, in this case, for the longest recombination frequency. So here we know that B and C is the longest piece there. Yeah, so maybe one of this, or maybe some of those are going to be located here. Do we have one intermediate in between some of this one? It will be some of those distance, but we already know that B and C are connected with a recombination frequency of 40. Now I'm going to take the second largest, and here, so we already have B and C here, and in addition to B and C that we did last time, now we had B and D. So here is B and D. So if you see inside of B and C, we have another 2 genes. Okay, so now we're going to see if there is another smaller one. Yeah, and we are going to take this one. Yeah, that is A and B. So here we have the following. Yeah, that is A and B, that is 15%. I am doing it in this organized way, and you can do it in a different way. Sometimes it's easier in this way, sometimes depending on the question, it will be easier to do it in a different way. So we already did B and C, and we find that B and D is there. And look now, A, B, and A. And I remind you that this is A and B, but this is the same thing that B and A. Here we are not talking, as I said before. When they give us this distance, they were not saying this is the first, A is the first and B is the second one. We are just saying these are in the extreme. Same thing in all of them. So B and C could be equal to C and B. Yeah, the C and B here. And this one is equal to D and B. And finally, this is equal to D and A. Okay, so here we put it the B and A. To be correct in this case, there is one option. One option is that the B and the A are connected here in the middle, in between the D and in the C. So yeah, this is one option. Another option, it could be that the A and B will be here. Yeah, and if we only have these 3 points, yeah, there will be 2 options. Yeah, it could be the option number 1 that I have here, or the option number 2. Yeah, because we don't know we so far this is the only sequence that we have that tells us about the information about A. So now, as we have more information, we can see if it's which one is correct. Yeah, so we will have to evaluate the following, that is A and D. That is 13. Okay, so let's go and try to solve this one in the following slide to see if it's option 1 or option 2. Okay, so now we finished this exercise, and here they gave us the other information about A and D. That is 13, and if you see 13 match perfectly here, yeah, so if you add 15 plus 13, yeah, you get 28. So the additive property, and here you have the 28. Of course, this is an example. If it was a real experiment, we are not going to get these numbers as perfect, so it will be 14.7 or 13, and yeah, but they are pretty close. Yeah. On the other hand, if we have the other option, A and B here, if A and B were here, this will not match. Yeah, they will be. It's impossible that the distance here between A and C will be 13. So, in other words, with this will be incorrect. How do you think that we can test this idea? How we make sure that this is correct? So we get more data. With the data that we have so far here, this is the best answer. But for example, we don't have this distance. Yeah, we don't have the D and C, and this can give us some questions. And how do you get the distance between D and C? So pretty easy. It will be 40, that is the large distance, minus 28. So this one, the large one, minus this one, and this will give us 12. So here potentially, based on the information, we will get something closer to 12 if we do that experiment. In addition, we also don't have the information between, let me delete this. Yeah, we have this distance, but we don't have the distance from A, yeah, to C. Yeah, from A to C, that it will be approximately from A to C. If this map is correct, it will be around approximately 25% of recombination. Yeah, so it will be 13 plus 12, or you can add it by subtracting our values over there. But in that way is that we know these things. Okay, so as a conclusion, let me show you. To answer this question, we got that the best order is B, A, D, and C. So B, A, D, and C. Again, this is we are not saying that B is the first one and C is the last one. So maybe if you don't see the answer there, the answer can also be C, yeah, D, A, and B. So it's the mirror image of this one. But here you can see that C and A is incorrect, so this one are not correct. B and D is incorrect. Okay, so this is why the best answer will be this one. So here we learn how to calculate the genetic map using the recombination frequency. A thing that I want to remind you, this additive property that we watch not in this video, but we watch in the first video about this exercise that you can give a look if you haven't watched it. Pretty simple. I want to remind you that this exercise, I try to make it easier, yeah. But in the lab, if you go into the lab, these values are not going to be as perfect. Yeah, it will not be. It will not add. For example, this 15 plus 13, and that you get a 28 perfectly. This will take too many samples. Yeah, and so to have it as close, yeah, generally you get relatively close number. And the third thing that I wanted to remind you of this is that we are talking about this sequence here, B, and here at the NC, It doesn't mean that this is the beginning and this is the end of the sequence. You can have here the mirror images. The only thing that we are saying is these are B and C are in the extremes based on this data, and A and D are in the middle. And the more data that we get, the more accurate genetic maps we can do. Okay, I hope that you enjoyed this. And if you have any question, let me know.